Hello, we are back for day 2 of Introduction to Vectors. So first we'll do a couple problems on solving navigation problems. An airplane is flying with an airspeed of 475 miles per hour on a heading of 70 degrees. If an 80 mile per hour wind is blowing from a true heading of 120 degrees, determine the velocity and direction of the plane relative to the ground. Okay, well, I'm going to start drawing this out. And first, I think I'll just kind of do a scale of 1 centimeter equals 100 miles per hour. Now, this doesn't have to be accurate at all because we're going to use trig to solve exact numbers. But I will try to kind of get it somewhat similar. So that has a true heading, 070. So I'm thinking, probably something like right along here. So I'll get myself an arrow and draw. And I need, almost 5 centimeters worth. 1, 2, 3, something like that. Yeah, something like that. Okay. And then we have an 80 mile per hour wind blowing from a true heading of 120 degrees. Well, 120 degrees would be, right about here. And so it's blowing from that. So I will grab another arrow and this one will be, I think I made it way too big. 80 degrees would be less than a centimeter, or 80 miles per hour would be less than a centimeter. So something kind of like that. Okay. Now to start solving this, because we want to know the resultant vector. So we should probably take this vector and stick her right here, and then know that we're going to have, oh goodness, well, I can't draw. So I will just use my pen. Our resultant vector will be something along these lines right here. Okay, and that is what we're looking for. So we're looking for the magnitude and direction of this green line. Okay. So let's start using some of the numbers that we know. We know that from the y-axis to the blue was 70, and the purple was right here. And that was 120, so that was 30, and this was 20. So right in here was 50 degrees. Okay. This is also 50 degrees then, because we have our interior angles, because this is parallel to this line. So this is 50 degrees here. We don't know this degree, but we do need to figure it out, really. Or at least then we can figure out how much it is from here. And then, on the plane relative to the ground. Okay, so from here to here. And we need to know this length. So we do know that this blue line was 475. And this purplish line was 80. So we can use the law of cosines to find this length or magnitude right here. And hopefully, I'm just going to write it down. See, you guys kind of remember this. C squared equals a squared plus b squared minus 2ab. This is really lagging. B cosine C. So I'm going to call this C this A and this B right here. So I'm going to solve for the length or magnitude of C, and I have my other two right here. So A squared would be 475 squared. B squared would be 80 squared. Minus 2 times 475 times 80. And here's my C times cosine, cosine 50. Well, as sloppy as that is, it gets really hard to write towards the edges. We're going to throw that into our calculator. And I got C squared is something huge and crazy like 183,000, blah, 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 blah. So then when I took the square root of it, I got that C is about 428 miles per hour. Okay, so that's one of our answers. That is the velocity. And then we need to get the direction. So if we figure out this angle in here, I'm going to switch colors. If we figure out this angle in here, we should be able to figure out this whole angle because we already know that this is 20 right here. Okay, so let's use the law of sines because now we know enough information. This is 428. So I'm going to use sine of 50 over 428 equals, and then I'm going to do sine of B, because that's the angle I'm looking for, over 80. Okay, I put that in my calculator, and I got sine of B is about 0.143, blah, 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 blah. So when I use inverse sine to find the angle of 1.43, blah, 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 I got about 8.2 degrees. So it asks for the direction of the plane relative to the ground. I would assume that that means it wants this, but maybe it wants a true bearing. Either way, we have enough information we can figure it out. So we can say it has a direction of 28.2 degrees, or we could say it has a direction of 61.8 true bearing degrees. I know that's a lot of trig involved in this. I don't think they're all going to be quite that bad, but at least it's more solvable than when you had to just estimate the direction and magnitude. Let's look at this one. Jamie rows her boat due east at a speed of 20 feet per second across a river directly towards the opposite bank. At the same time, the current of the river is carrying her due south at a rate of 4 feet per second. Find Jamie's speed and direction relative to the shore. So I'll just say 1 centimeter equals 5 feet per second. And I will get myself some arrows here. So due east 20, so we will just 5, 10, 15, 20, say that. And then the current is due south at a rate of 4 feet per second, so we will, whoops. This is trickier than it looks, I promise. All right, so almost one of these. Oh, that's close. Okay. And then I'm going to use the whole kind of tip to tail method. And I know that that doesn't even look straight. Okay. And then we will need to find this. All right, something like that. So I'm going to go ahead and this was 20 feet per second. This was 4. And we need to find the direction. Now this is nice because this we have a nice right angle. This whole due east, due south thing is wonderful. So we can actually use Pythagorean theorem to find the magnitude of the resultant vector. And then we can also use just right angle trig to find the degree right here. So let's do that. Pythagorean theorem, we'll do c squared is going to equal a squared plus b squared. So c squared will equal 416. The square root of that is about 20.4. So 20.4 feet per second is the length of this vector. And then we can find the degree here. So I will just use opposite over adjacent. So tangent of x equals 4 over 20, opposite over adjacent. And then I will have to use the inverse of that. And I'll throw that in my calculator real quick. And I get 11.3 about. And since that's 11.3 degrees right in here, we can use, let's just do a true bearing and just add it on to 90 degrees. So we get that. So we have a speed or magnitude of 20.4 feet per second. And we also have a 101.3 degree true bearing. Okay, last thing we will do is resolve a force into rectangular components. And this is pretty simple. Let's read about it. 2 or more vectors with a sum that is a vector r are called components of R. While components can have any direction, it's most useful to express or resolve a vector into 2 perpendicular components. Those are going to be your horizontal and your vertical. Okay, those are your x and your y, pretty much, just like a rectangular or coordinate plane. So, while digging in his garden, Will pushes a shovel into the ground with a force of 630 newtons at an angle of 70 degrees with the ground. Draw a diagram that shows the resolution of the force that Will exerts into its rectangular components. So basically, we have, okay, this is 70 degrees. We have an interesting little triangle that I can't draw. And this is 630, because that's our newtons. And what we need to find is going to be, and this was supposed to be straighter, our y, or our vertical, and our x. So we're just going to use some right triangle trig to figure out our vertical and our horizontal components. So I'll do the horizontal first. So we have x comma y, and we have adjacent over hypotenuse. So we need cosine. So cosine of 70 is equal to x over 630. And then to get the vertical component, we're going to have opposite over hypotenuse. So we'll need sine of 70 equals y over 630. I'll throw those into my calculator. Okay, and then so for the horizontal force, I get 215.5 newtons approximately. And then for the vertical, I get 592 newtons. So this is my horizontal and this is my vertical. Let's try one more. I'll try to go through this quickly so you can be done. A player kicks a soccer ball so that it leaves the ground with a velocity of 39 feet per second and an angle of 37 degrees with the ground. Find the magnitude and the horizontal and vertical components. So we have the ground, and I seriously wish I could draw straight. We have a ground, and we have 37 degrees, which this is not drawn to scale, 37 degrees and a velocity of 39 feet per second. Okay? We need to get this vertical and this horizontal. So I'm going to label this one Y, this one X, and I'm going to set it up as opposite over hypotenuse. So sine of 37 equals Y over 39. That's going to be my vertical. I should write the other one first. And I will write my horizontal up here, cosine of 37, because it's adjacent over hypotenuse, equals X over 39. And then I'll throw those into my calculator. Okay, so for my horizontal component, I got 31.15. And that is going to be feet per second. And then for my vertical, I got 23.5, or I guess 4.47. I don't know how far we're supposed to round it, but those are my horizontal and vertical components. All right, good luck on this assignment. If you have any questions, just let me know. Okay, I was also just looking at the assignment and I was thinking number 44 is kind of a challenge. And it's not too bad as long as you realize that you need to do the tip to tail, the triangle method of the resultant, you need to move one of those vectors so that it is a tip to tail. If you don't move it, you're going to end up with the wrong answer as you figure this out. Just go ahead and try it and see what you can do.